Greetings children. Today we will study about the tangents of a hyperbola. So you already know the equation of hyperbola. So shape of the hyperbola will be like this one. This is the x-axis known as the transfer axis, and this is the y-axis known as the conjugate axis. Say equation of hyperbola is x square upon a square minus y square upon b square is equal to 1. We are studying about a tangent. A point is given on the hyperbola, say x1, y1. We have to find out the equation of tangent at this point. So you know, tangent is a line which touch the hyperbola at one point. So this is the point where we have to find out the equation of tangent. So point is given x1, y1, and equation of hyperbola is given x square upon a square minus y square upon b square is equal to 1. We have to find out the equation of tangent. This is known as point form because point is given on the hyperbola. So first of all, differentiate the equation. After differentiation, you will get, we are differentiating with respect to x. So you will get 2y upon b square as it is, dy by dx is equal to 0. So what is the value of dy by dx? You will get from here, if you transfer the quantities, so x upon y into b square upon a square. That is the dy by dx. So slope of tangent is when you substitute the value of x1, y1 in place of x and y. That is b square upon a square into x1, y1. That is known as slope of tangent. Now slope you know, point you know. You can find equation of tangent. So equation of tangent will be, use point slope form, y minus y1. Slope is b square x1 upon a square y1 into x minus x1. Simplify this. You will get, if you multiply y1 this side, y1 minus y1 square. B square transfer to the left hand side, you will get this one. And x1 multiply with this upon a square also. It becomes x1 upon a square minus x1 square upon a square. Now this term transfer to the left hand side and this term transfer to the right hand side. You can see which type equation you will get, x1 upon a square minus y1 upon b square is equal to x1 square upon a square minus y1 square upon b square. Now children, you know this point lies on the hyperbola. If this point lies on the hyperbola, it will satisfy this equation. So if you put in place of x, x1, in place of y, y1, you will get x1 square upon a square minus y1 square upon b square is equal to 1. Use this relation here. So value of x1 square upon a square minus y1 square upon b square is 1. So I will replace this by 1. So equation of tangent becomes x1 upon a square minus y1 upon b square is equal to 1. That is known as equation of tangent of the hyperbola x square upon a square minus y square upon b square is equal to 1. And this is also known as point form. Point on the hyperbola x1, y1 is given. So we can say point of contact for this tangent is x1, y1. This is the point of contact. So whenever hyperbola equation is x square upon a square minus y square upon b square is equal to 1, then equation of tangent is x1 upon a square minus y1 upon b square is equal to 1. Directly you have to remember this formula. Now next I will tell you the another form, parametric form. You know children the parametric coordinates of the hyperbola. So we can take parametric coordinates as a sec theta, b tan theta. That is known as parametric form. So in the point form equation of tangent, we replace x1 by a sec theta and y1 by b tan theta. You will get the equation of tangent in parametric form. So do you remember in point form, equation of tangent was x1 upon a square minus y1 upon b square is equal to 1. Now x1 replaced by a sec theta. You can see, children, what is the changes now? In place of y1 put b tan theta upon b square. So you can cancel a square, b and by square of this. So you will get x upon a sec theta minus y upon b into tan theta is equal to 1. This is known as equation of tangent in parametric form. And next form is slope form. So third one we can say equation of tangent in slope form. Slope form, I already told you when we have done the derivation of y is equal to mx plus c is the tangent of the equation. So condition for that we have find out there, c square is equal to a square m square minus b square. If this value we replace in the place of c, y is equal to mx plus c, then we will get the equation of tangent slope form. Y is equal to mx, value of c is a square m square minus b square. This is known as equation of tangent in slope form. Point of contact you can find with the help of solving the equation of hyperbola and equation of tangent. You have to do put the value of y in place of this, and then you will get a quadratic equation in x, solve it, you will get the equal roots. So value of x will give you the x coordinate of point of contact. Put the value of x here, you will get the point of contact of y coordinate. Okay, so point of contact also you can find. In the module I have given the point of contact of all the three types, tangents and equation of the tangents. Children, one more thing, if the center of the hyperbola is not origin, in that case equation of the hyperbola will be x minus h whole square upon a square minus y minus k whole square upon b square is equal to 1. If this type form is there, then equation of tangent in point form is given by x minus h into x1 minus h upon a square minus y minus k into y1 minus k upon b square is equal to 1. So remember, if center is not origin, in that case equation of tangent in point form. Second, I will tell you the slope form. So in place of y there will be y minus k, in place of x there is x minus h. Remaining things you have to keep it as it is. That is the equation of tangent in slope form. So these two formulas also you have to remember. This will help us to solve the equations. Children, in this example, the equation of a tangent to the hyperbola 16x square minus 25y square minus 96x plus 100y minus 356 equal to 0, which makes an angle pi by 4 with the transverse axis is. It means you have to find out the equation of tangent. The slope of tangent you can find because tangent makes an angle pi by 4 with the transverse axis. So first of all convert the given hyperbola in the standard form. This is the hyperbola. So first of all convert into standard form 16x square minus 25y square minus 96x plus 100y minus 356 equal to 0. Now take the terms which are containing x together and y together and constant term transfer to the right hand side. Here if you take 16 common you will get x square minus 6x. Here if you take minus 25 common you will get y square minus 4y is equal to 356. If you convert into the standard form you will get 16 times x minus 3 whole square minus 25 times y minus 2 whole square is equal to 356 plus here you have to add 9 into 16. and subtract 4 into 25. If you simplify this, transfer the terms to the left hand side, you will get equation like this type. So x minus 3 whole square upon 25, y minus 2 whole square upon 16 is equal to 1. So standard form we have converted now this one. This is the standard form. Slope of the tangent is given here. What is the slope of tangent? M is equal to 10, angle is given pi by 4, 10 pi by 4 is 1. Now you know, if this type equation, then in the slope form, equation of tangent, so I told you y minus 2 is equal to m into x minus 3 plus minus root a square, value of a square 25, into m square minus b square root. Simplify this equation, you will get the equation of tangent. So y minus 2 is equal to x minus 3 plus minus. Simplify children this, you will get plus minus 3. So if you take plus 3, you will get y minus 2 is equal to x. Or if you take minus 3, you will get y minus 2 is equal to x minus 6. So one equation is y is equal to x plus 2 and another equation is y is equal to x minus 4. Children, see which option is matching with your options. You can see y is equal to x plus 2. First option is matching with this and x minus 4 is not given here. So only A answer is the correct one. So y is equal to x plus 2 is the correct option for this question. In this question, the point of intersection of two tangents to the hyperbola x square upon a square minus y square upon b square is equal to 1. The product of whose slopes is c square lies on the curve. It means we have to find out the locus of the point of intersection of two tangents. So you know children, if equation of hyperbola is this x square upon a square minus y square upon b square is equal to 1, then equation of tangent is given by, you can write in slope form, y is equal to mx plus root a square m square minus b square. That is known as equation of tangent. Suppose point of intersection of two tangents be h comma k. It means this tangent passes through the point h comma k. This point lies on this. So in place of y put k, in place of x put h. That is the equation of tangent which passes through the h comma k. Simplify this. If you transfer the ms to the left hand side and squaring both sides, you will get quadratic equation in m. Further simplify, you will get m square h square minus a square minus 2mkh plus k square plus b square equal to 0. This is a quadratic equation in m. So it will have two roots, say m1 and m2. Then sum of roots and product of roots you can find. Sum of roots and product of roots. So what is the value of product of roots? m1 into m2 is c upon a. C is the constant quantity, that is k square plus b square. A is a coefficient of m square, that is h square minus a square. And this value m1 into m2, product of their slopes, is given in the question c square. So in place of m1 m2 I am writing c square. This is given in the question. Now simplify this and then find the locus of h and k. C square into h square minus a square is equal to k square plus b square. So what is the locus of h comma k? To find the locus, we have to generalize the equation. So in place of h put x or in place of k put y. So it becomes x square minus a square is equal to y square plus b square. Now children, check which option is your correct option. So y square plus b square is equal to c square into x square minus a square. This will match with the C option. So C option is the correct option for this question. In this Question, children. If the tangents drawn from a point on the hyperbola x square minus y square is equal to a square minus b square to the ellipse, equation of the ellipse is given here, x square upon a square plus y square upon b square is equal to 1. Make angles alpha and beta with the transfer axis of the hyperbola. Then which option is the correct option? We have to find out the value of tan alpha and tan beta, either their sum or their product or their difference. First of all, let us suppose a point on the hyperbola. Let us suppose point be h comma k given on this hyperbola. So this will satisfy the equation of the hyperbola. So we can say h square minus k square is equal to a square minus b square. First equation you can say. Now we have drawn the tangent on this ellipse. So equation of the tangent of the ellipse in slope form is y is equal to mx plus root a square m square plus b square. This is the equation of tangent, and this tangent passes through the point h comma k. It will satisfy. So in place of y put k, in place of x put h. You will get k is equal to mh plus root a square m square plus b square. Simplify this. Transfer mh to the left hand side. So you will get k minus mh is equal to root a square m square plus b square. Now squaring both sides. So you will get k square plus m square h square minus 2 times m kh is equal to a square m square plus b square. Now transfer all the terms to the left hand side. So you will get quadratic equation in m, h square minus a square minus 2mkh plus k square minus b square equal to 0. This is a quadratic equation. So you know it will contain two roots, sum of roots and product of roots you can find directly from this equation. So what is the sum of roots? Minus b upon a. It becomes 2kh upon value of a is h square minus a square. And product of roots is c upon a. So you will get k square minus b square upon h square minus a square. m1 and m2 are the slopes. Now they have given that tangent makes the angle alpha and beta. So we can say value of m1 is equal to tan alpha and value of m2 is tan beta. If you substitute the value of tan alpha and tan beta in place of m1, m2, you will get m1 plus m2. It becomes tan alpha plus tan beta. Its value is 2kh upon h square minus a square. And m1 into m2, it means tan alpha into tan beta. So its value becomes k square minus b square upon h square minus a square. Now we have to find out the locus of h and k. So put the values here from equation 1. The value of h square minus k square is equal to k square minus b square. Now in the second equation, this I am saying second equation, from here find out the value of k square minus b square. Transfer the terms, this one you will get h square minus a square is equal to k square minus b square. This value substitute over here, you will get tan alpha into tan beta is how much? Numerator is h square minus a square divided by h square minus a square. So you will get tan alpha into tan beta is 1. Now you can check the option, which option is correct. Tan alpha into tan beta is 1. C option is matched with this. In this example, if the line 2x plus root 6y is equal to 2 touches the hyperbola x square minus 2y square is equal to 4, then the point of contact is. The equation of tangent of the hyperbola is given. Now we have to find out the point of contact. Children, see here, equation of hyperbola. This is not given in the standard form. First of all, convert this equation into the standard form. So if you divide the whole equation by 4, it becomes x square upon 4 minus 2y square upon 4 we can write like this way. It becomes x square upon 2 square minus y square upon root 2 whole square is equal to 1. So value of a is here 2 and value of b is here root 2. That is the value of a and b you will get from the standard form of the equation of hyperbola. Now equation of tangent they have given 2x plus root 6y is equal to 2. Convert in the slope form. So it becomes y is equal to minus 2x upon root 6 plus 2 upon root 6. So you can see from here minus root 2 upon 3x plus root 2 upon 3. That is the equation of tangent, and point of contact we have to find out. If we compare this with the y is equal to mx plus c, and value of c should be a square m square minus b square square root. A and b you know, value of c and m you know. Apply here, you can check the condition. Now point of contact is given by, if y is equal to mx plus c and value of c you can say, I am writing the value of c here, a square m square minus b square. This is the equation of tangent. Then point of contact is plus minus a square m upon root a square m square minus b square plus minus b square upon root a square m square minus b square. Now children, put the values here. So values of a, m and b. A you know 2, a square is 4. Value of m you can compare with this. So value of m is minus root 2 by 3. Minus root 2 by 3. This is the value of m upon a square m square minus b square. Its value directly we can use root 2 by 3. C value I have written directly. And then y coordinate is plus minus b square, that is 2 upon this value of c is here root 2 by 3. Simplify this, you will get minus plus 4 plus minus. If you simplify this, you will get root 6. So you are getting the point minus 4 plus root 6 or plus 4 minus root 6. These are the 2 points of contact we are getting. Now check which option is matching with the given options. They have given minus 4 and root 6, that is not given here. So this option is not possible. Another is 4 minus root 6. So this is given here. So D option will match with the given option. So this option is the correct option of this. Children, in this example, number of real tangents can be drawn from the point 5, 0 to the hyperbola x square upon 16 minus y square upon 9 is equal to 1 is. You have to find out how many tangents we can draw from the point 5, 0. So main thing is here, you have to find out the position of the point 5, 0. This type hyperbola is there, whose equation is given here, x square upon 16 minus y square upon 9 is equal to 1. I can write minus 1 equal to 0. This value I am saying s. So value of s is x square upon 16 minus y square upon 9 minus 1. If you put the coordinates of the point 5, 0 in place of x and y, this value is known as s1. So in place of x put 5, in place of y, so you will get value of s1 is 25 upon 16 minus 1. It becomes 9 upon 16. That is positive value. Positive means this point lies inside the hyperbola. Now tangent you can draw when there is a point either outside the hyperbola or on the hyperbola. Then only you can draw the tangents. If point is inside the hyperbola, then no tangents can be drawn. It means in this question you can't draw any tangent that will passes through the point P. So number of tangents you can draw, that is 0. So which option is the correct one? C option. Children, many questions I have given in the module. So you have to do the practice from the module also. In the next lecture, we take the next topic about the normals.